Alright, welcome back. It is now Wednesday, and I uploaded that video last night. I'm just starting to clean up. I have gone through all the resistors, at least in the bottom. I still have to check the resistors in the tuner, which are going to be accessible via the top. I did check there's like a 4 ohm wire wound resistor in the horizontal output tube filament just below the base. I tested that. That was fine. And I did test the doorknob cap. It's 20 kilovolts at I think it's 500 picofarad, and it tested at, I think it was like 496, so that was pretty good, give or take. I mean, I know that's kind of hard to do with the leads showing some capacitance too, but anyway, it was there. I even did a leakage test on it, but obviously I could only go up to 1,000 volts, and it was fine, no leakage. So what I think I'm going to do next is finish cleaning off the desk a bit, and I think what I want to do is, even though I ohmed out the transformer, I think I want to apply some power to this and test the different transformer windings for voltage with no tubes in them. So I'm going to go ahead and finish tidying up a little bit, and then I will we'll do that. We'll fire it up and see if we can make some smoke. So I will be back. Okay, so went ahead and cleaned up a little more, and I've got plugged into the Variac and got it set at 117 volts, so go ahead and turn it on, and I think you can see there that the violet lamp is lit. Let's see, I'm assuming it's the original bulb, but it's marked like the bulbs I've taken out of the Philco sets. Actually, they has the tongue saw and then the number 47 on it. I think it says 47. Although this parts call for a 51, I think, but it has a 47 in there. In fact, the hood, or the lens cover, I guess, whatever it's called, looks like it was made for a 47. I mean, yeah, so you can see that there. Now I'll probably break the bulb, watch. I will actually probably swap that out, because with my luck, I'll get the TV all in there, turn it on, and then while I'm testing it, it'll blow up. Okay, so, sorry about that. Alright, so as you can see, we have 117.7 volts going through there, and there's no smoke so far. Okay, so I'm going to hook this up to ground here. And okay, so the rectifier's here, so I suppose between here and here we should get about 700. Okay, 775. I believe it calls for 370, so that's 640, plus there's no load on it, so we'll call that one good. Should be getting 5 volts across the yellow here. Okay, 5.3, looks good to me. This is the main, maybe you can see that. The main 6.3 volts, which is actually X, I believe, which also powers the UHF, is this one here, and it's got some pretty hefty, it just basically has big hunks of metal. This is why I don't want to take the transformer out. See if you can... Oh, this is in the way. Yeah. You can see that? Nope. Well, it's big and it's metal. And it's stiff. Alright, so... Okay, well that one's up to ground, so there we go. 6.6 volts, those are the green windings. And then there's two other red ones, which go to the high voltage area, which would be, I guess I should be careful. Don't touch anything, Brett. Okay, 6.5, so that's good. Come over there. Be good. Alright. And then we have the last one, which is Y. And it's these two black ones. Here and here. So... I guess that goes up to the filter. 6.5, okay, so transformer's good. Although I guess we kind of figured that out. I believe the pilot lamp is also on X, so that would have kind of been our clue too. Alright, so transformer's good. I guess the next stop would be turning this up on its top. I don't know what I'm going to do next. I got so self-absorbed or so absorbed with the resistors, I kind of... Oh, I guess the other thing I was going to do was, you know, I had to buy some coating. So I picked up some of the Aerodag, which, by the way, is super expensive. And then I picked up slip plate. Those were the arguments between the two I saw online. This is all, it used to be known as Aerodag G, but I guess it's now called Bondurite aerosolized graphite lubricant. It does actually say on the back somewhere, cathode ray tube. Anyway, what I was going to say was just for the heck of it, I sprayed some of the slip plate onto some glass. And I sprayed the Bondurite onto another piece of glass just to test which one is more conductive. And then I also tested the glass on, or the coating that's remaining on the CRT. So it's from end to end, the longest portion on the CRT, from near the neck to the front, is 7 inches. So I measured on that one a little over almost 1.1 K of resistance. I don't know how much resistance matters, but I sprayed 7 inches of slip plate, 7 inches of the Bondurite, and with the slip plate I got just about 3K of resistance, but with the Bondurite I got about 300K. So like I said, I'm not sure that matters too much as long as they conduct, but I just found it interesting because this seems to be a little more conductive than this does. Wasn't exactly a scientific test, but at any rate, I'm going to go ahead and use the slip plate instead of this. This is in alcohol, and it's a lot runnier than the slip plate, which is in acetone and regular paint kind of stuff. So this goes on thicker, this goes on thinner, and this conducts better than this. Again, like I said, I don't know how much important that is, but anyway, I'm going to use the slip plate because it's stickier. So anyway, I think I'll go ahead and upload this because I think the next parts I'm going to do are going to be pretty boring and mostly cleanup and painting. So I do have to rebuild this couplet. The part should be here Friday. So anyway, thanks for watching, and I will post an update soon.